On today's episode, we are demystifying DAS systems. Welcome to the show where we tackle the tough questions submitted by installers, project managers, estimators, and even ICT personnel. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being produced? If you're listening to us on one of the audio podcast platforms, would you mind just giving us a 5-star rating? Those couple little steps helps us take on the algorithm so we get this information out to more people so we can educate, encourage, and enrich the lives of people in the ICT industry. Thursday nights, 6 p.m. Eastern Standard Time. What are you doing? We have a live stream on TikTok, LinkedIn, Facebook, YouTube, where you get to ask your favorite RCDD, well, that would be me, questions about installation, certification, project management, even career advice. But I can hear you now, Chuck, I'm driving my truck home. I'll go get in an accident. They're recorded. You can go back and watch them on any one of those platforms. You can also access them through our website at letstalkcabling.com. And finally, while this show is free and will always remain free, would you mind consider becoming a Patreon member where you can get additional access to me for questions, anything like that? You can also go to our Linktree account. I'll put up the QR code right here, and you can access me. You can buy me a cup of coffee. You can even schedule a 15-minute one-on-one Zoom call with me after hours, of course. So as I mentioned, DAS systems is one of those things that we've all heard of it. Some of us are actually doing it. And I came across a guy on LinkedIn, and I saw in his title that he was a DAS person. I was like, would you be interested in coming on the show? And he said yes. So we're going to talk about DAS and what it is and why you should get into it. So welcome to the show, Phil Leaf. How you doing, Phil?
Hey, good. How are you doing? Appreciate you having on me here today.
My pleasure. Give the audience a 30 to 45-second interview of who you are and why should we listen to you?
Absolutely. Yeah, my name is Phil Leaf. I work for Mobili-Fi right now. I'm a solutions engineer for the RF industry. Been doing this for about 12 years. I started in what we call the macro world. So basically those cell towers you see outside as you're driving down the road. Started in the cellular industry, moved into more of the DAS, the distributed antenna systems, which brings you more of inside the building, the venue, taking you inside of spaces for that cellular connectivity. And basically from there, worked on cellular projects to public safety projects to anything that was basically RF DAS related is what I'm doing nowadays.
Very cool. So do you have structured cable experience?
I have some. I'm actually an electrician by trade. That's how I really stumbled into this one. Became an electrician. Kind of saw a need during the 3G upgrades, as you hear about 5G now. Running a lot of copper T1s. Before when fiber was still kind of in its infancy days. So I've got a little bit of that cabling background.
Well, it's just our secret. I can't let everybody know that I'm letting electricians on a low voltage show.
Good to know.
So that's just between us and the 5 or 10,000 people that actually download the show. So what is a DAS?
So yeah, a DAS. I'm going to give you what I've used before as kind of the definition. A distributed antenna system, or a DAS, is a network of separated antennas connected to a transporter or medium, typically by coax, category cable, fiber optic cable, that provides a wireless service within a building or an infrastructure. Now, in layman's terms, antennas all over the place inside your building that distributes that wireless signal throughout the whole building. So no matter where you are in the building, you have that cellular connectivity or the RF connectivity for either a two-way radio, your cell phone, so on and so forth.
I never really thought about this before, but I've done work in a lot of large buildings. The Pentagon being one of them, sports stadiums, a bunch of others. And I am not an RF engineer. I'll be the first to tell you that. I'm a cable guy. And I'll tell you, concrete and steel knock down RF signals by a lot. And there's been more than one occasion where I've been in one of those buildings and you just don't have, first you lose your internet connectivity on your phone, right? And then you lose all cellular connectivity. And while that might be an inconvenience, and I could see it as a value add for like a sports venture, where they can, that way you can keep track of your team, whatever. But it's also a safety thing too, right?
You absolutely got it. I'm glad you brought that up. Public safety right now is a big push. It has been since 9/11. I wish it was a stronger push since then. But ultimately 9/11 really brought the public safety two-way radios into, the public's eyesight. So we're seeing it implemented into the fire codes, implemented into the building codes, being mandated, anything below a certain dB RF level. I do IB wave designs for the RF as well. Studying the architectural plans from low E glass to double poured concrete walls, below grade. Where's the building? Is it on a hill? Is it down in a valley? Those are things that we're taking more into consideration. And yeah, I think we're really seeing the push on that. That's, like you said, that safety side, that concern. The cellular world, we all want to be connected. We want our phones to work. Absolutely.
Would a tunnel be an environment for a DAS system?
Oh, absolutely. Yep. We are, we're basically seeing below grade parking structures, tunnels, the large venues, they got their obviously their capacity, the amount of people they have, but we got hospitals out there that are connected via tunneling systems and things like that. Schools with tunneling systems, they're all within that range of, needing a system.
Yeah, because that thought just crossed my mind. This is how my ADHD brain works. Because as you're sitting there and you're talking, I was like, I've driven through many a tunnel. I'm not going to show you how old I am. I've driven through many a tunnels, listening to my AM talk radio shows as a young technician, and you'd get about 200 feet in that tunnel, and that's it. It's done until you're coming out. And I just got to thinking, well, what if you're in the middle of the tunnel and your car breaks down, or there's an accident, or someone needs to call 911? So I'm assuming they're putting up, I guess, whatever. So other than tunnels and hospitals and what was the other one we talked about just a second ago? My brain just kind of went brain on me.
Any large venues, stadiums, concert venues. Basically we're seeing all of those places. They get the priority. From at least from a cellular standpoint and from a safety standpoint. We obviously want to make sure that connectivity is good in and out. I would say we're really starting to see the multi-dwelling, the apartment buildings, which, for us, LV cabler guys, that's right up our alley. We're already in there implementing some of the fire and the Wi-Fi systems. Why can't we be doing the DAS either from a cellular standpoint or from a public safety standpoint?
That's very interesting. So let me ask you this: would the same DAS system co-host both the 911 or the emergency stuff and the other stuff, or are those two separate DAS systems?
That's a great question. As of right now, how we sit today, we really push them out as separate systems. We have seen some grandfathered systems who are able to piggyback off the same cabling system. They've had to go through and upgrade some of their components, but the two-way radio system for the public safety is separately derived. We typically end up having some survivability factors for those systems. 2-hour fire rating for the risers and the chases. Some of the conduits and the cables that need to pass through our 2-hour fire rating rooms. NEMA rated fork boxes. We're really seeing that separate system, and obviously to a cost come with it as well.
Right. Yeah, I would imagine your emergency services DAS systems would have probably a couple levels of redundancy built into it, where a standard, like you said, multiple dwelling or maybe a sports venue, it might have some redundancy there, but it's not as critical if someone can't download the score of the competitor's team, as opposed to an EMS unit trying to call out for hey, we're at such and such portal, meet us there with the LS unit. I could definitely see that. So when you're talking about the system, you're putting in, I guess, antennas, and you're connecting the antennas with some type of media, either like you said, copper category rated cabling, fiber, or coax. Which do you find is probably the most used of all those medias?
Yeah, absolutely. We typically say coax is the traditional way of installing a lot of these systems. As 5G and as the technologies evolve, all of the OEMs out there are trying to evolve their platform as well, which that's where we're seeing, fiber optic being, become really the main driver there from network all the way to the edge. I mean, they're trying to basically eliminate as much copper in between as you can, shoot fiber all the way to the edge to the antenna. But again, you change over from that traditional coax to that category cable, copper cable, to that fiber. Again, you come with a little bit more of a cost. And at that point, from a cellular standpoint, the carriers are not really funding these systems too often. We're not seeing it, a whole lot anymore. So it's really coming down to that building owner. So really, it's what can you chew? What are you looking to accomplish, within your facility?
You bring up a good point. So, are you saying that? And I'm not actually speaking for the entire industry, but in your experience, are you finding that the building owners are the ones really funding the cost for all this?
Absolutely. Yeah. We're seeing it more and more. From a cellular standpoint, the carriers are very, very, very focused on 5G, getting it in the outdoors. So really, like as we work with carriers right now on a day-to-day basis, they're funding their attention towards in-building cellular systems is it's very little unless you're a stadium. So we're starting to see those building owners who have got the multi dwellings who want to rent out their spaces. They really gotta come to play to keep up with the rest of the competition. So I mean, if safety obviously is number one, so they're going to get that public safety system put in place, but at the same time they're going to go, yeah, let's take a look at this cellular issue. We don't. Some tenants walk in the building and say, "Oh, I like the way the wallpaper looks." Some tenants walk in the building and say, "Oh, I like where the Wi-Fi in my cellular is at." So,
I was going to say that Wi-Fi has become the third utility. I mean,
absolutely.
most people nowadays, that's almost one of the first questions you ask. Do you have Wi-Fi? What's the Wi-Fi password? And some people are making consumer choices on to which buildings they're going to go to, which houses they're going. I mean, which apartment buildings they're going to rent based on their connectivity availabilities,
Yep.
and that's
Yeah.
a huge thing. So, getting back to the media question, so we can use coax or fiber or category rated cabling. Well, we know that RFI is radio frequency interference. If we're talking about RF systems, so I would have to assume that coax or fiber would be the better of the two because they're more immune than category rated cable systems are, unless you put it in conduit, which maybe you can elaborate. There's a lot of them in conduit or not. Which do you think is going to be the better suited for the long term, for the building owners putting a bunch of money in this building to attract business?
Yeah, absolutely. If we're going to talk from a cellular standpoint, I would really say, fiber. Fiber is the future. It's looking for those speeds we're looking for. When we talk about cellular 5G, you definitely need fiber optic in place in order to get up to those speeds, the bandwidth, so on and so forth. Uh, we're really trying to get away from, as you said, conduit, metal. We worry about in the RF industry about PIM, passive intermodulation. PIM is created basically from metal. We try to stay away from metal shavings, metal, obstructions, things like that. And as the fiber optic systems come out, and we're getting that fiber all the way to the edge, that's just something we don't have to worry about.
It's not very often that the acronym guy gets stumped. When you said PIM, I was like, what? Personal information management?
Oh, I could show you some. Or I'll send you some DAS acronyms.
Oh, absolutely,
And
absolutely.
you,
I think that's going to be my next set of my next set for the acronym challenges because I like the acronyms. I really do. I really
yeah,
do.
yeah. That I tend to use some sometimes. That do people look at me, deer in the headlights, and I'm like, oh shoot, I forget. Cellular world talks differently. I will use my
And that's why I
acronyms.
do, that's exactly why I do the acronym challenge,
I
because
like
not everybody is at a 40-year RCDD level. Some people are. I'm only been in the industry for 6 months, and I still don't even. It's like learning a new language.
yeah.
So my whole idea, the whole reason I do the acronym challenge on LinkedIn every day, except Sundays, is to kind of bridge that gap. That's the whole reason I do the acronym challenge. So explain to me, you said the PIM. Can you explain a little deeper what is that? Why does that interfere with digital antenna systems or distributed antenna systems?
Yeah, absolutely. So, in the cellular DAS world, we're always worried about noise. We're always worried about, from a quick understanding of what noise is in the cellular world. It's the equivalent to taking that microphone that you're talking to the group in front of, and you take that microphone and you go walk it back to the speaker. And the closer you get to that speaker, the louder the noise and the hum gets. Uh, so that is what we call our noise, our interference, and PIM, passive intermodulation, typically comes from when we're shooting that RF signal out of the end of an antenna, and we're either reflecting off of the metal back into it, or the cable could be even properly terminated improperly. So as they terminate the cable, the coax copper cable, they get those metal, tiny aluminum shavings inside the connector, inside the coax cable, and they hook it up, they send it out, and the next thing you know is we're creating PIM on the system. We're shooting noise back into the DAS system. So when you actually go to use the DAS or use your cell phone, you're not going to use it properly. You'll start hearing that static, that gargle, or that loud hum like you'd hear from that microphone. So it's something that we end up actually testing for. We have testing gear that tests PIM, allows us to test it at a certain decibel level that the carriers are saying is a safe reading. Certain intermodulations that we then send through the coax cable. It bounces off a termination load, heads back to the tester, and gives us our pass-fail test result, allowing us to test that coax cable, get it installed properly, and move on with a properly installed DAS.
That is so interesting, because I've always been into CB radios and ham radios. I mean, I don't have a ham radio license. I'm working towards getting one, but
Cool.
the whole RF side always interests me. Always had a side interest there. I just had other hobbies that took higher preference, like photography and motorcycles. Right after those two hobbies, I don't have a whole bunch of money left over for the radio hobbies for some reason. Go figure. All right, so we're running some type of medium to some type of antenna. Or is it one type of antenna, or are there multiple types of antenna? Is the antenna chose on the materials or the area that you want? What is this? What's the deal with the antennas?
Yeah, absolutely. So while we're in the design phase, that's typically where we're choosing our type of antennas. A lot of them look like a dome recessed can light that would typically hide within the ceiling tile, in the drywall, however the aesthetic pleases. So that's your typical standard, just dome antenna. From there, we have directional antennas from all different sizes, from a sheet of paper, some even the size of an outlet cover, that go all the way up to, the size of the window behind me is, some of the sizes we have in the stadium style venues. And those directional antennas, those are doing exactly what they're meant and they're called out for, directing, pointing that signal right into a tunnel, a hallway, down a set of bleachers, maybe even up in the air. We actually have some antennas in the downtown area that take care of some of the high rises, and they have to point upward. So yeah, we've got all different types, sizes, connector types of antennas, but really, as we're in that design phase, that's where we're really going to make that choice per the location of each antenna.
Gotcha. So we're installing antennas, basically, the type of antenna based on where we're trying to transmit, and also the aesthetics. Because trust me, customers want aesthetics. they they seem to care more about aesthetics sometimes than performance, don't they?
You are absolutely correct.
Yeah. Trust me, I've dealt with customers like that before in my realms. So I've got an antenna and I've got a piece of copper, a piece of fiber. How does that connect to that antenna? Is there a piece of electronics between the antenna and the cable, or is it just plugged right into the antenna?
Yeah, it depends. So our traditional coax type, a lot of that is either done via home runs, depending on your venue. But a lot of the times that's a daisy chain. You'll run your coax down the hall where you would either hit a coupler or a splitter. A splitter does exactly what it says. It divides it into two ways, three ways, or four ways. A coupler takes and couples the value and takes only a certain value down and shoots it one direction and maybe shoots a stronger signal the other direction. So as you're heading down the hallway, you'd hit that coupler value. That coupler would then divvy up the signal to go down the hallway one direction, down the hallway the other direction. And you could either end it at an antenna there or again, hook up to another coupler splitter and keep kind of daisy chaining down and throughout the building. Well, again, we run into limitations with cable distances like every wonderful cable does. And again, our coax, after we hit that 300-foot range, is usually going to start giving us that RF loss, or we're going to run into other problematic issues. So that's where we really could dive deeper into the difference on those passive DAS systems to active DAS systems, where an active DAS system uses fiber optic cable throughout the entire building to a remote location, where that then remote is transmitting that fiber optic over to copper cable. And again, we're back out to our traditional, coax copper out to the antennas. So yeah, it's your standard antenna install. If you're familiar with a Wi-Fi WAP install, it's a lot like that, just a lot bigger cables and possibly less home runs.
Right. So you mentioned the distance limitations. Coax can actually run longer than category rated twisted pair cable can in certain environments. So, but you mentioned the 300-foot number with coax. Is that an issue? I mean, after 300 feet, you really run into a problem with coax with DAS?
Yeah, so yeah, absolutely. So we're not always getting the exact same signal from our repeater, our BDA, our signal source, if you will. A BTS system that's going to give us a transport via fiber optic from some sort of either carrier or backhaul connection. We typically can drive that a little bit further than what's needed. We also use software, what's called IBWave. IBWave allows us to do predictive analysis, put all the coax cable in place, all the couplers, connectors, antennas, turn it on like a light switch, see how it's going to propagate through the walls, through the windows, into the next building, to the next room, so on and so forth. So, yeah, as we get to a repeater system, I can only get so much power from the roof that I will eventually, yes, run into some sort of limitation when it comes to the end of my coax cable.
So, are you sending power over the coax, or the antennas stuff being powered remotely?
That's the RF power sent over through the coax to the antenna and out the end of the antenna through the radio, back through the antenna, the uplink, back to the repeater. If there's an antenna on the roof, up out the antenna on the roof to the transport, and back and forth it goes.
So, I guess with fiber, you're sourcing your power remotely, or using some kind of a hybrid fiber so you can run power over it.
Absolutely, no, great question. So, yeah, we will. So, if we have a full DC system, a lot of the times we'll have a DC power plant, and then yes, we will. We could either run over Volt server, or we'll run over the DC power plant, where we've got DC remotes, fiber, DC power within that that hybrid cable. Or yes, we will ask for house power, and they will end up putting some house power out at those remote locations. And again, you got to be careful. Is it house power? Do you need to be on UPS house power type? So on and so forth. So yeah, that's a great question.
Yeah. So I got that part down. Now the only part missing is, okay, how does the signals get onto the DAS system? I mean, how are you making that connection to the cellular provider, or how are you making that connection to the spectrum or the internet provider?
Yeah, absolutely. Yeah, I touched on that a little bit before. I used the words the base station, the BTS system, and then also our BDA, our bi-directional amplifiers, our repeaters. I'll start with the simple one, the repeater, the BDA. You've got a head end unit, a brain. that has an antenna up out on the roof. That antenna out on the roof is looking for that signal. Either we're dialing it in with one of those directional antennas right at the tower, or maybe we're just picking up everything. From there, the signal comes in through the antenna on the roof, into the repeater, from the repeater out through that coaxial system, and then out through the antennas to the end users using either their cellular phones or their two-way radios, which then again goes back up through the antenna, back to the repeater, up and out the roof. That is what we're seeing traditionally from the public safety standpoint. Those are all done that way. We are also seeing a lot of the small solutions for carriers done through those repeater BDAs. And then the second one I talked about was that BTS, that base station, that backhaul feed. So either we're getting a backhaul feed via fiber optic from directly the carrier, or maybe we're getting a fiber optic from a local LEC around nearby, and then our carriers or whoever is going to tunnel in through that transport. From there, that is connected into your typical switches, routers, things like that. From there, we go from fiber into usually carrier radios. The carrier radios then are injected into that DAS system, typically an active DAS system. And then from there, that head end gear, we inject the carrier signal all the way up and out to either those remotes or out to right directly to the end antennas.
Very cool. Very cool. So let me ask you this. You're an electrician. You know the whole low voltage versus high voltage thing that's always going on. Is this something that somebody who's currently a low voltage contractor is doing voice and data systems? Is this something that they're capable of getting into?
Absolutely. This is right up their alley. And honestly, get it out of the electrician's hands.
You said that, not me. Not me. I didn't say that.
Let's be real here. Let's let the real cabling guys get the right cabling put in place. That's exactly it. I mean, I work with a lot of low voltage firms here in the Midwest area, doing exactly what you're saying. We want to get all of them on board with not just the one trick ponies of going out to do just fire alarm or just to do the Wi-Fi structured cabling, whatever it is. Exactly. DAS, whether if it's public safety or cellular. We want them to be able to feel comfortable pulling in a cable. A lot of the times they see that 1/2-inch coax and people get a little intimidated, and it's gonna kink or we're gonna hurt it. You get one under your belt pulling this stuff in. It's a walk in the park, and once you realize how you can daisy chain some of this and you're not home running all of it, it really becomes a real nice niche for a low voltage contractor to come in, cable this stuff up, and either work with another integrator. You don't have to come in and do the integration, the commissioning, the smart side of the thing. You can hire other contractors for that type of side. So yeah.
And we do that now in the network world, right? There are some cable contractors, they just do cabling. An integrator will bring them in to do the cabling portion, and then there are some contractors that will offer both services. And I do want to clarify, there are some great electricians out there, some great electricians, but there is some feedback about there are some electricians who look down on low voltage. And because of that, they don't really give due diligence to low voltage, meaning it's just they treat it like regular electrical cable. Oh, we can yank on this as hard as we want. That fiber, we don't have to worry about bends in it. There are some of those, but there's some bad low voltage people too. So it's an equal world. So Bixie has they don't have a book dedicated to DAS systems, at least not to my knowledge. Now I know that they do have a small section in their TMM, but it's very small. It's where would somebody go to try to maybe get some additional training on DAS systems?
Yeah, that's actually a pretty tough question. A lot of it right now is being done online. You can reach out to some of the OEM manufacturers that are out there. Some of them do some training. You can reach out to some of the manufacturers that make a lot of the coax and the connectors. They are very big into helping with coming to even to your shop, bringing chunks of cable, bringing the termination tools, giving you a list of what it is you need to, buy or have on in the van or on the truck to get it done. So, from the installation side, that's a way to go. Myself, reach out to me, through you, however, so forth. And I'm sure too, a lot of guys are working with vendors that they order their cable and their material through. Reach out to your vendors. I'm sure most of them already have an avenue of where to buy the cable, which then means they can give you an avenue into getting some training done for terminating, testing, things like that. And typically from there, once the doors open up, it's all about how deep you want to go and dive into it.
So what if somebody wants to get more on the design side? Where would they go for training for stuff like that? Kind of like you. They want to be the next you.
Hey, absolutely. So right now, IBWave and RanPlan, those are the two big design tools that are out there. And really anyone can go to their website, sign up, take some pre-qualification courses. You can do some just like training, talk to like the reps, chat a little bit, get familiarized with something and see if maybe it's something you like. And they do that through IBWave and through RanPlan. So, either or, a little bit of Googling as well. YouTube's pretty cool these days.
It can be, but anybody can have a YouTube channel. I'm a perfect example of that. And this old boomer can do a YouTube channel. Anybody can do one. Right?
Yeah, and it's nice because they also have design levels. Level 1, level 2, level 3, so on and so forth. So you really can take it as fast as you want, slow as you want.
That's interesting, Zach. So I got to ask you, where's the most interesting place that you've installed a DAS system?
Yeah, I'd probably have to say US Bank Stadium here in Minneapolis, Minnesota. I was a part of that from day one. It was a 2.5-year long process. For a long time there, it was considered the largest DAS in the United States. There's some other stadiums out there that have taken the title now. But yeah, just to kind of put things into perspective, there's 70,000 fans that can be held in there, and typically we put in a cell. Like if we had to put it into how many cell towers we put inside the stadium, we ended up putting 70 cell towers inside the stadium in order to hold that capacity. We were talking somewhere over 10,000 antennas throughout the building. Hundreds of thousands of feet of fiber and coax. It was a very fun project. Multiple teams involved. At the time, US Bank Stadium was on the verge of course, holding the Super Bowl. So we were in this crunch time, this rush to get it across the finish line. All carriers on, all capacity, all issues taken care of, and yeah, it was a success and something that I definitely look back on still today.
Yeah, I've worked in some interesting places in my career too, and I always ask that question. So let's say that you convince somebody. And there's a cable contractor listening to podcasts somewhere. It's like, man, this sounds like something I can do. What do you recommend be the first couple steps? How do they dive into this? Do they contact an integrator like you, or how do they pursue this kind of work?
Yeah, I would, say, I would try to reach out to an integrator, and if you can't go down the integrator route, I really think going through one of your local vendors. They're typically probably, they probably already have somebody that they know exactly who to work with or who to, give a number to. That's really, I think, the start. Because really, if you've talked to that vendor's also, I think, going to go, well, hey, let's get you to talk to some of these guys who make the stuff. How comfortable are your guys pulling in the cable, terminating the cable? Do you want to even test the cable, or are you just no, we want to pull in, hang the antennas, and we're going to call it quits there? Or no, we'd love to be turnkey. We want to go put these BDA systems in, start, turn, test. A lot of the times it's get to know an integrator, learn what the integrator is doing, and either you can figure out how to do that yourself, or you keep that partnership, that friendship alive, and hopefully you both can continue to bring in work together.
It's all about relationships, and then you also have to decide what portion do you want to do? That doesn't mean you can't do the whole integrator package and installation package, but you may not want to bite off on that first. You might want to kind of just jump in, do the installation side first, because there's been many projects for where we've just pulled the cable, and then somebody else will put in the routers, and then later on, as we got more proficient with and we hire people who know how to do networking, we would end up giving a whole turn package. You may not want to do that overnight. Something you might want to kind of work yourself into.
Yeah, absolutely. I mean, especially with the public safety side being in the code. I mean, do you really want to jump into putting a system in that you go, ooh, we didn't quite study the code on this one to see 2-hour rated, where do we got to pull cable? It's nice to have a little bit of a hand holder through the first one, I'd say.
Yeah, it's funny because my backup because this show will actually publish tonight. My backup content for tonight's show was because I all the time I see people, because I'm on all kinds of social media all over the place, and I hear, well, that doesn't meet code. I'm like, okay, well, there's codes, there's standards, and there's best practices. Code is the minimum of all of them. You want to be far exceeding the code book.
Oh, absolutely.
But I'm still going to do that show, though. I'm still going to do it because a lot of people don't understand the difference between those three. They just don't.
Yeah. The authority having jurisdiction. He wants you to hop on one left foot and hold the cable in there. You hop on one left foot and hold the cable in the air.
And you ask, do you want me to whistle a tune while I'm doing that?
So right. Absolutely.
But the local authority having jurisdiction is usually not well versed in DAS systems, well versed in category rated cabling or fiber optics. I mean, look in the code book. It says in the code book you can staple cables. Yeah. I dare you to staple a category 6A cable. I double dog dare you.
No thanks. Yeah, no, that's the DAS right now in the code and everything. It is, yes, it's still we like to call it still the Wild West. You know, where if we can draw that line early in the stages, let's get it in the right way. Let's get it done safe, efficient. Yeah.
Is there an organization for DAS, kind of like how Bixie is to low voltage? Is there one for DAS systems?
So not necessarily. I will say right now out there is a group called the Safer Building Coalition. I'm not sure if you've heard of them or not. The Safer Building Coalition, they're a big advocate right now for the public safety DAS systems. Since, like you just said, since AHJs, inspectors, fire inspectors, other things like that are not as adverse in the systems or understanding the systems, understanding the survivability needs, things like that. They've taken it upon themselves to really go around on a national level and help educate on a very, very big level, going around hitting up every sort of, venue and location that they can for conferences and really getting the word out there of what, public safety DAS is, how we test it, the testing equipment that's in place today, kind of where we're looking at it in the future and in the codes. So, I'd say they're the big advocate right now. And I'm sure we're going to see more, as obviously the NFPA and the code really adopts. And
yeah, it takes a while for the code book to catch up with what we're doing in the field. It just does, and that's because it's a slow process. I mean, they revise it every 3 years, and our industry moves at the speed of light. We don't wait 3 years to come up with something new. So
right.
Where do you see DAS going in the future?
It's really going to be the future. You talked a little about that Wi-Fi, and honestly, Wi-Fi I can see starting to take the back seat to DAS, to cellular DAS. More and more you'll hear about things like private LTE, CBRS, private spectrums. So really, as we get into the private LTEs, the CBRSs, the private spectrum really allows more security, more private, more break off chunks of that availability. So as we really move on to the fiber to the edge, fiber to the radio, fiber to the antenna, we're going to move toward that smart city, that smart building. Building automation is following right in that footsteps. So really, if building automation wants to survive, it's going to need the technology behind it to really keep it going. So I was a part of a smart city, smart technology group at one point in time where we were really coming up with what does the future look like. And at one point, we actually had the conversation of the farmer no longer needing to go out and get in the combine, to get in the trailer, to get in the tractor. He now sits down at his office and
let me talk to you about farmers. So those who watch my show, they know I've got a homestead. I've got a 3-acre homestead in Central Florida. We raise ducks and chickens and geese and goats and pigs and cows and all kinds of fun stuff. I am not a farmer, but I pay attention to what farmers are doing because I learn from them. You go out and buy a brand new John Deere tractor trailer. It's got a very sophisticated computer connected to a GPS system where it can actually plow an entire field without touching a control. Farmers are hiring drone operators to fly over their fields to see if what areas are getting enough water, what areas are growing faster than. I mean, being a farmer is not just, well, it is growing soil and getting your hands dirty, but it's way more technology advanced than a lot of people realize.
Oh, absolutely. And I love it too, because a lot of people are like, oh, farmers, they probably tell you to go, pound sand, technology, no way. Actually, they are the most interested in our technology and where the future holds for them. Because that is their livelihood. That is, that's how they make their dollar day to day. So if we can come up with an infrastructure, technology in place that allows them to just sit at home, tell everything what to do, and they can diagnose and digest exactly what it is that their crops, their fields, their machines are doing. That hey, if he can now go spend time with the family, I think that He'll take that any day. So it is. It's really going to move towards hopefully helping more than it will to the negative side of things. But yeah, and into the big cities, we're going to see the self-driving cars. We're going to see the cell phone obviously advance. We're going to see us being, more interconnected. We're already on the verge of doing surgeries from one side of the country to the other. That 5G, the way that we're trying to do hospitals, buildings, the city, our daily life. It really it is going to get impacted by it. We're already seeing it, I think, in the homes. With the in-home internet coming out for the Verizon, AT&T, and T-Mobiles of the world. I've even got some friends already that have said, I don't have a Wi-Fi bill anymore. I actually now just have my cell phone bill that covers my cell, my Wi-Fi, my work from home status. And that's, easy button. That's where we're moving toward.
Absolutely. Phil, if somebody wants to get in touch with you because they've got a DAS system that they want to help them design and then get installed at some point, how do they get in touch with you?
Yeah, you can find me on LinkedIn. Hopefully we can do a little post of just some of my information. phil.leaf@mobilify.com. Super easy. I'm quick to respond. I've, like I said, been doing this for 12 years. It's something that I'm very, very passionate about. I don't like to leave people high and dry, working with all the low voltage contractors on a national level. And I'm here to help. That's for sure.
And I will say this, he is quick to respond because I saw him in a LinkedIn thing. I think I tend to do my podcast stuff after hours. And it was after hours when I sent the initial request. Hey, I want to do a show about DAS. I mean, boom. I was like, man, he's working like I'm working. So yeah, he is very quick to respond.
I appreciate that. I always like to say, if I'm going to work in the technology industry, making my phone bigger, better, faster, no matter where I am in the world, well, I better prove it. So
yeah. Very cool. Phil, we covered a lot of stuff. I think this is going to garner some additional interest in DAS. I'm going to have you back on. You up for that?
Absolutely. Yeah. I love talking this. So anytime, any day, you just let me know.
Sounds good. Until next time, everybody, remember, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.